Hey guys, and welcome to this webinar. We're going to be talking about Kubernetes today on Azure Kubernetes Services. Just a little introduction about WinElect and who we are. We are WinElect, and we have core services of consulting, instructor-led training, and on-demand training. We are a consulting company. That is primarily what we do. We offer a lot of consulting services in the Microsoft space, specifically around Azure. We also do instructor-led training, and that's where we bring our instructors to your business and train you up on technologies. And we also do on-demand training through our online portal, wintelectnow.com, where we have world-class instructors that teach on the latest and greatest tech in the Microsoft space. And just a little bit more about us. We are industry influencers in that we have many authors who have worked for WinElect over the years. One of our more popular authors was Jeffrey Richter, and is also one of our founders, and he wrote one of the seminal texts on C#, Core CLR in C#. And we also have Jeff Procyse and John Robbins, who are our co-founders as well, who wrote many other books in this same vein, working with C# and different things related to technologies such as ASP.NET, Xamarin, and Silverlight, and many other technologies like that. So some highlights: we have been Microsoft Gold Partner for several years in multiple competencies. We have a lot of Azure MVPs on staff. We have DevOps Rangers. Our CEO is the regional director for Atlanta, and we have a lot of other competencies specifically in the Microsoft space. I personally am an Azure MVP, specifically focused on open source as it relates to Azure, and I also have a specialty in containers. So let's talk a little bit now about Azure Kubernetes Services and what Azure Kubernetes Services is. So first and foremost, Azure Kubernetes Services is a offering from Microsoft. It basically gives you a full-blown Kubernetes stack that is managed by Microsoft. Now, when I say managed, I'm basically saying that the service is something that Microsoft gives you that you don't really have to go in and patch. So you don't have to patch the virtual machines. You don't have to patch the Kubernetes installation. You don't have to do a lot of hands-on work with the servers. Microsoft takes care of that for you. Now, it is a shared responsibility in some respects, but it does give you the ability to upgrade the version of Kubernetes that you're using. If you want to customize some things on the nodes that are running in the cluster, you can do that, and it does give you the ability to do some more fine-grained control over those nodes, but the bulk of the work in terms of managing it falls to Microsoft, and it's generally a best practice if you're using Azure Kubernetes Services to not worry about trying to manage those VMs and the Kubernetes cluster yourself, only worry about upgrades and focus in on deploying your workloads to those. Azure Kubernetes Services is easily scalable in that you can add nodes or remove nodes to it, and it also supports auto-scaling now to where you can use automation that's built into Azure to add more nodes based on the capacity and the metrics that are coming out of the Kubernetes cluster. Like, say your CPU utilization is above a threshold of 75% on average across all of your nodes, and you want to increase the availability of pods on your Kubernetes cluster, you can automate that process or go up and down within the context of Azure Kubernetes Services. It fully integrates with other things on Azure, like Azure Application Gateway and load balancers, as well as Azure Storage, Azure Blob Storage, Azure File Services, and Azure Disk for storage mechanisms. It can also integrate with Azure Active Directory for role-based authentication, and a number of other services on Azure that gives you a very integrated experience using Kubernetes, but with a very Azure flavor to it, so that you can take advantage of everything that Azure offers while you're running Kubernetes. And then it also supports most of the common Kubernetes features that you would come to expect. So if you want to run something like Istio, or you want to use Helm, or any of those other plugins that will work with Kubernetes, those will work as well. So it gives you the best of both worlds in terms of being a managed service and integrating with Azure, as well as being a Kubernetes experience and giving you everything that Kubernetes offers in a single offering on Azure. Now, one thing I did not mention is that with the Azure Kubernetes Services, you you only pay for the nodes that you use to run your workloads. Now, a typical cluster such as Kubernetes, you will have management nodes that you need to run the cluster. With those management nodes, those are virtual machines, and in many instances, you have to pay for those nodes as well as the worker nodes that actually run your applications. With Kubernetes, you don't have to pay for the master nodes. You only have to pay for the worker nodes, which is some value add for using Kubernetes services on Azure. So let's skip over container registry. We're not going to be talking about that today. So basically, what is Kubernetes itself? Kubernetes is a container orchestration workload that will give you the ability to administer and manage containers at scale. So you can do automated deployments. You can scale workloads up and down. You can manage those workloads when they're in production and monitor them for things like health. You can also scale them out horizontally and do things like self-healing in the event that maybe a node drops, so that you can move workloads around. And it provides infrastructure to the hosting environment so that you don't have to go out and configure a bunch of infrastructure to do things like common networking, like to route packets between one part of your application and another part of your application. Say you're running a database and you want to be able to connect your application to a database that is running in another container. You can use the infrastructure that Kubernetes supplies to you will automatically configure a lot of that plumbing that you don't have to do that under the hood. Kubernetes is also open source. It's not a technology that's owned by Microsoft, and it's actually owned by the Cloud Native Foundation, which is a nonprofit that's responsible for governing the Kubernetes work and the open source project itself. No one owns it that is a corporation. It actually came out of Google, but is become the de facto standard in container management online. And so many other clouds such as AWS and Google Compute also have container offerings built around Kubernetes as well. And because it's open source, you can also deploy it on premise. And so Kubernetes as a service really does give you a lot of options, not only in Azure, but across other clouds as well. But we're specifically talking about the Azure implementation today. So what is the most fundamental building block within Kubernetes? Well, that would be something called a pod. And the pod itself is basically a wrapper around containers. So in Kubernetes speak, when I talk about a pod, I'm talking about the most basic unit. And most folks get this confused with containers when we talk about containers in the context of Kubernetes, because oftentimes there's a one-to-one correlation between a pod and a container. However, in Kubernetes, you can actually put multiple containers in a single pod. Usually that's not a best practice unless that second container is what we call a sidecar container that's doing some administrative work to support the primary container, which is the one that's actually running the application components that's contained in that particular container. But in any case, the pod architecture looks like this, where you have a name. All pods use and have a name, and that is used to resolve that name on a network that is within the context of Kubernetes. Second, pods have labels, and this is useful for doing things like organizing your pods and doing what we call selectors across your pods, so that you can use like key value pairs to say, I want all the pods that are supporting databases, and you can use selectors inside of Kubernetes to isolate a particular application or deployment for those given pods. And this would apply, labels don't apply specifically to pods, they apply to pretty much everything on Kubernetes. Next, you have storage, and storage is at the pod level, and it's mounted storage from either the host or some external file source, such as an NFS share or Azure File Storage or Azure Blob Storage, or even Azure Key Vault, which gets mounted into the pod that can be read by the applications in the pod as part of the file system. And storage is important for pods so that you can have persistent data in the event that your pod gets taken down and moved to another node. It can then remount the same storage inside of that pod and use it accordingly. So those are kind of the three components of pods, and the pods will also be useful for administering CPU and RAM utilization, as well as network resources within the context of the container. So Kubernetes containers are used uses containers for deploying apps. In most cases, these are Docker containers. Now, Kubernetes does support a lot of other container engines out there, but the lion's share, probably the 99th percentile of all containers running on Kubernetes are going to be Docker containers. And there's other container formats out there, but that's really not those are more edge cases for more historic workloads that were using container formats before Docker became more popular. But for most cases, when people are talking about containers in Kubernetes, they're talking about Docker containers in Kubernetes. And that is the assumption for this video and most of the work that I do in Kubernetes as well. So with that in mind, I do want to talk about the next thing, which would be Kubernetes controllers. Now, once we talk about a pod, the next thing that we have to talk about in the context of a pod is something called a controller. And a controller is basically the thing that controls a deployment of pods, plural, on a Kubernetes cluster. So a pod is the most fundamental unit. A controller controls the behaviors of those pods. They manage the things like scaling those pods, the health of those pods. They ensure that the pods that are running the application meet the desired state as defined by a given controller. So whenever we talk about Kubernetes in general, you'll hear the word controller used a lot to refer to things that are on Kubernetes that are responsible for managing some aspect of Kubernetes. The term applies mostly to pods in applications. However, it can also refer to more generally to things like network controllers and other things like that on Kubernetes. And there are several different kinds of controllers that we can talk about. The most common types would certainly be the middle three there: deployment, stateful sets, and daemon sets. The first two are replica sets and replication controllers. Are two older controllers that were first introduced with Kubernetes and have largely been supplanted by deployments, but you still may see some references to replica sets or replication controllers, while deployments are the more common one among just a basic set of pods that you want to have a certain quota of pods available for your application to run. A stateful set is a little bit different from a deployment set, and it's basically used to run applications that have dependency needs between the different pods that are running. Say you need them to come up in a specific order, so you would define in the daemon set, bring up my database first, then bring up my application, or something along those lines. And the last two are jobs and cron jobs, which are basically for running tasks that are long-running tasks, such as batch processes or things that are administrative tasks, such as reporting that get run on a schedule, which would be cron jobs. These kind of things are useful for supporting applications that are running in deployments, stateful sets or daemon sets. Daemon sets are another interesting one that are used for making sure that a single pod or at least one instance of a given kind of pod runs on all of your nodes in your cluster. So you have your worker nodes. Every single one of those worker nodes will have at least one copy of the given pod in that particular node. And this would be good for things that you need to have something maybe monitoring the node, or maybe that you want to ensure that the scale of that given component is available across the entire cluster, and that it's resolved locally without having to traverse a network or some use case like that. Daemon sets are useful for that. So the two most common types, as I mentioned, would be deployments and stateful sets. So with the controllers in mind, I want to look at the actual architecture for Kubernetes, keeping in this idea of controllers in the back of your mind so that you can see the architecture as we discuss it in this slide right here. So with a Kubernetes cluster, you have the master nodes, and then you have these things that we call worker nodes that are responsible for running your pods. So we looked at pods already, and the basic architecture of this is pretty standard for most container orchestrators, where you have master nodes and worker nodes, and the masters, it has several components. Now, the Kubernetes nodes run the actual components. I want to illustrate some of the key components of architecture of Kubernetes, mostly so that you're familiar with this, because in dealing with Kubernetes clusters, you'll see these things referenced, so that whenever you see a particular implementation of Kubernetes, even on Azure, some component on Azure will be represented maybe by the native component or by something else, such as etc. D inside of Kubernetes, which on Azure Kubernetes Services is beginning to be replaced by Cosmos DB, which has a etc. D database that you can use with your container orchestration engine. So these can be swapped out for other components. But by and large, you have an API controller, and that's what you interact with something called kubectl, which is the utility that you use to actually run and interact with your Kubernetes cluster. And we'll look at that in a demo later on. You have controller managers. Remember, we talked about controllers a minute ago. The controller manager is what's responsible for orchestrating those controllers that get deployed onto all of the Kubernetes nodes that are actually running, and it's the piece that is responsible for governing the code that is inside of your controllers, that in turn goes to impact the actual pods on the Kubernetes nodes themselves. Next, you have the scheduler, which is the piece of the Kubernetes cluster that is responsible for marshaling resources and managing the balance of pods across the nodes that are running on your Kubernetes cluster. Etc. D is a key value store for storing configuration information. Kubelet is the component of any node that is a worker node that is responsible for receiving commands from the API controller to actually do something on the node. So the API controller gets something from the scheduler that says create this pod, and the API controller goes down and says to the kubelet, create this pod on your node, and the kubelet will then download the image from a container registry, start the pod, and then will attach it to the network and then have it up and running. And then all the while it's reporting back to the API server and the actual scheduler of its progress. The next component is cAdvisor, and it's basically a metrics it's a gathering metrics about the pod and reporting those back to the Kubernetes master. And the kube proxy is another important component. It's basically the piece that exposes your application to a network. So it's the part that's going to do the load balancing across your pods on your given Kubernetes cluster. So if you're going to define load balancing schemes like round robin at a TCP load balancer for maybe a database, that's going to be handled by the kube proxy. Or if you're going to do something that we'll look at in a moment with Ingress controllers, and you want to do URL-based routing, the kube proxy is also going to be responsible for that. And then lastly, there's the pod and the all-important overlay network, which provides the network abstraction so that the pods appear as if they're on a contiguous network, even though they might be going through another virtual network, such as Microsoft Virtual Networks on Azure, but it appears as a single contiguous network across all of your nodes. And this can even be configured across VPNs and things like that as well. But the plugin driver for Azure Kubernetes Services is a specialized driver specifically built for Azure for doing this network overlay across the Kubernetes nodes running on Azure Kubernetes Services. So let's go to the Azure portal and look at a demo on setting this up. And then I've already got one set up, but I just want to look at it briefly. So we can launch a browser window here, and let's go to the Azure portal and log in here. And I'm going to log in as me. And I have here my Azure Kubernetes cluster already defined right here, but I'm going to create a resource and go through the wizard, basically that Kubernetes Services provides in the Azure portal, and talk through some of these various things here. Now, every Azure Kubernetes cluster requires that you create a resource group, and I'm going to call mine Kates for short. And that's so that I can create a Kubernetes cluster. And you have to give it a name, so I'm going to call mine Kates as well. And this is where I can select my Kubernetes version. There are supported versions in Azure that are constantly being added. So a few months ago, 1.13 was the default version. That's been updated to 14.8, but now there is some availability for 15.5 and 15.7, and they have a few preview versions as well. And with Kubernetes, clusters on Azure, you can always upgrade, but you can't go back. However, what you can do is you can create something called node pools, and we'll look at that in just a minute and what that is. And here is the options that I have for creating the node count. Remember that those worker nodes, I can scale up to 100, although I don't have that many vCores enabled on my subscription. So I can set it to 1 or 100 on this. And I can also change the size of the VM to another size available on Azure. So if the standard offering, the D2S V3 with 2 cores and 8 gigs isn't what I needed, I could use a smaller VM, a DSV2, or I could use a larger VM, such as a 4 gig of RAM VM here. And there are a lot of other options. I'm just showing the filtered version of what's available, but I'm going to stick with the default, which is a DS2 V3, which is 2 cores and 7 gigs of RAM. Next time I can set scale. Here, I'm not going to be able to demo these, but virtual nodes allows you to use the Azure container instances for nodes on your Kubernetes cluster as well. So you can use Azure container instances to attach to your Kubernetes cluster and apply works to those Azure container instances that are billed by the second. And the minute you shut the pod down, the billing stops. However, with a standard node on Kubernetes, you're paying for the VM, basically, the utilization of the VM. And so whether you have anything on there or not, you're paying for it 24/7 as long as your container nodes are up and running. While a virtual node, it's paid for by the second, and the minute you start it, the billing starts, and the minute you shut it down, the billing stops. So this is an interesting concept right here. I'm still a little bit hesitant to use it as of right now because there's still some bugs that they're working out, but even so, as soon as that becomes available, it'll be good for things like batch processing that gets processed on compute that's not a part of your main cluster. So that's got some use cases, I think, for providing billing options on a Kubernetes cluster that are more in line with your actual usage. And VM scale sets allow for multiple node pools, and it will also add for auto scaling features as well. Authentication, here I can enable RBAC, and RBAC on Kubernetes is useful for doing role-based authentication against the Kubernetes cluster. This is good for multi-tenancy, or if you've got multiple administrators or a lot of developers that are going to be using it. Enable authentication and authorization is good to control roles on it. If it's just you and it's going to be a small cluster, you can turn that off and it works just fine as well. The networking components on this, you can have the HTTP routing turned on, and this will allow you to integrate this with a application gateway with some special Ingress controllers. We'll look at one of those later on. And this down here with advanced networking or basic networking, this allows you to define a custom VNet for your cluster. The basic networking won't expose the VNet for you, but if you have a custom VNet, this will allow you to have things on your Azure Kubernetes cluster that are part of another set of virtual machines or other resources that are attached to the same VNet. So this allows you to use Kubernetes as part of a larger deployment on Azure, such as using something like Azure SQL for your databases that are connected to your Azure VNet by way of something like Private Link or a service endpoint without having to actually run that as a container node. So the integration with Azure VNets opened up a lot of possibilities for integrating Azure Kubernetes Services with a lot of other parts of Azure. There's monitoring solutions available on Azure. The native one is container monitoring. There's 2 levels of monitoring that are part of Azure Kubernetes Services. One of them is the actual monitoring of the cluster itself, which is going to monitor all of your nodes and give you health statuses and dashboards and things like that for the Kubernetes cluster. And then you can actually get container monitoring for the specific containers on the nodes as well. So you have both of those available inside of Azure Kubernetes Services. The one for monitoring Kubernetes itself is turned on by default. If you don't want container monitoring, you don't have to turn that on, but it becomes a part of a workspace that you can look at, and then you can get metrics about your containers. You can get logging and that kind of thing out of your containers. Tagging is available for Azure Kubernetes clusters. That's so that you can use Azure tagging. That's not related to pod tagging or other resource tagging. And once you have that all defined, you can hit create and go. Now, with once I have that ready, I can click go. I don't think this is going to validate because I skipped some stuff. But even so, once I click go, it takes about 20 minutes. Actually, that did validate. It takes about 20 minutes to deploy, and your cluster is ready for use. So let's go back to the deck and look at some other stuff related to some basic concepts as it comes to Azure Kubernetes Services, or more in general, Kubernetes itself. We've already looked at this. And let's look at services now. A service on Kubernetes is basically a set of pods that are exposed through a load balancer. So when I talk about a service, I'm exposing a deployment of some kind, some kind of controller through the kube proxy. So with Kubernetes, everything that you want to connect to a network, really, you can connect a pod to a network, and that works. But generally speaking, you're not going to be using a single pod to deploy an application. You're going to be deploying that through some sort of deployment. And the deployment then can be attached to something called a service. And the service is what gives you the ability to do load balancing across a set of pods. And so it's a type of controller that does the networking for you. This is for TCP load balancing, though. So whenever I define a service, I'm really looking at either a load balancer, which is a TCP4 based load balancer that gets a public IP address and attaches it to a pod that acts as a load balancer across all of your other pods, and that's the kube proxy. I can also deploy it as a cluster IP. Now, cluster IP is basically a private IP address that gets exposed as part of the Kubernetes cluster. And then I can expose it as something called a node port. And a node port, it uses a specific IP on a given node and uses one of the ports on that given node. So the difference between a node port and a cluster IP is a cluster IP will be a single IP address that represents all of the pods that are being load balanced by the given IP address, it's delegated as a separate entity than the actual IP address of the node itself. The node port, it uses the node's IP address, and it just exposes it as a port. So essentially, the node port has its use cases for a lot of dev test type work. I've very rarely used it in production workloads. However, load balancers for external IPs, I've used a ton, and cluster IPs I've used for internal addresses on the network. I've used a ton as well. And so both of these are very important for defining workloads on Azure Kubernetes Services. So I want to go through a demo on services. This is one of those things I think that's better shown than talked about. So I can go back to my file system here, and let's pull up a little demo here that I have defined for this already. Now this file here is what we call a manifest file inside of Kubernetes, and basically what a manifest file does is it defines controllers and services, or what we'll talk about in a minute, Ingress. So this is going to define basically the workload that I wanted to run inside of my Azure Kubernetes Services here. So first thing that I've defined in this is I had to find a service, which we just mentioned. And so what I did here is I did expose it as a load balancer. So basically I'm telling Kubernetes I want a public IP address on port 80. And that's basically saying I want to run a web application. This is not consequential to anything. I just named it HTTP. So I have a load balancer on port 80 that is going to expose a deployment that is, remember, I can do replica sets across a bunch of different nodes. So, but in this case, I'm only going to deploy a single replica of my application, and I only have one replica, and so I have a single service on a deployment that's only going to have one replica. And this is where I define my container down here. So this is where Kubernetes meets Docker, and this is in my container spec. And I'm telling it to go get this image, and this is an image I built to do demos with. And basically what I've done in this image is it installed something called DOSBox, which allows me to play old DOS games in a container, and it streams the results back to a browser. So I'll go ahead and launch this, and we'll be able to see this in a demo. So what I'm going to deploy is a service and a deployment inside of my Kubernetes cluster. So I'm here inside of my my cluster here, and I'm going to go into I think that was demo 1, and get a list of my directory. And I'm going to call kubectl. I've already connected this to my Azure Kubernetes cluster, and that's done through a command that looks like this right here called get credentials. I use the Azure CLI and call AKS get credentials, and I tell it what resource group and which cluster I want to use, and it will add the cluster credentials for my AKS cluster into my local cache of credentials for my Kubernetes CLI. So once I have that as my Kubernetes CLI joined to my my cluster, I can then call Kubernetes control or kubectl and do create and do -f and then call keen.yaml, and this will create that resource on Kubernetes. Now this is going to take a second to do, so what I can do is use some other kube commands to get the status of that. So if I go kubectl get service, it's going to list me the services. In fact, it's already done that. It's already deployed it, so that went really fast. And if I do get pods, it's going to list the pods that I can get, that I have. It's actually creating the container right now, so it's pulling that image, but it already grabbed the external IP address and assigned it to a load balance and an internal IP address for routing. And I can then get the status like that, or if I want to get some information about it, I can do kubectl get describe pod, and then that will give me some detailed information about the actual pod, if I can actually spell this, and that will give me some detailed information about the pod right here. And it's actually pulling the image right here. You can see the what it's doing behind the scenes right here, and you can see some other information about what ports it's exposed on. You can see some other information about the kind of pod it is. It's running on Linux, what cluster it's running on, and so on. So if I do the get pods again, should be, I see it's up and running, and I can now grab this service IP right here and pull this up in a browser. So let's go back to my browser here, and I'm gonna go http:/, this is running on that, and it's going to give me a directory listing, and I'm going to launch this, and I'm going to plug in, this is a web page now that is running on my Azure Kubernetes cluster. I failed, authentication failed, let's type in my super secure password here, and maybe I can type it in, and this is DOS box running an old DOS game running on a Kubernetes cluster, streaming the results back to a browser. Then I can install my little game here, and this is installing an old DOS game. So if you've ever played old DOS games, you can now do that on Kubernetes using this little container that I built that's designed for running DOS games on Kubernetes. And here it's running Commander Keen. If you've ever played this game, you had an awesome childhood, and it's basically just streaming the results back from that container to a browser through WebSockets, and that's basically just a web technology that gives me socket connection. So again, I just deployed this to Azure Kubernetes Services, and it's up and running. So let's go back to the deck now and look at one other concept on Kubernetes. And no, this is Ingress. Now with Ingress, the ability to use Ingress is the ability to do HTTP-based routing, and this is useful for internal services. So with HTTP Ingress, what you can do is have a service behind a web server that is working as a reverse proxy against those services. So this basic architecture here, I have what is essentially a reverse proxy that's an Ingress controller that will receive HTTP requests. Now I can use this thing for things like HTTP load balancing. I can use it for SSL offloading. I can do header injection. I can do all that kind of stuff that we come to expect from a reverse proxy on something like an F5 type device, but that's all built into Azure Kubernetes Services. And it can also do things like define routes, URL-based routing that can then be farmed out to various services like we just saw exposed on ports inside of a Kubernetes cluster. And so the route would then route it to route 1 would go to one set of replica set of pods, and route 2 would go to this set of replica pods. And that will give me the ability to have a single point of entry for an application, and then the URL itself will then determine which pods get the request, and then the Ingress will then forward it on to that particular set of pods. So with that in mind, let's go back and look at another demo related to this, because Ingress is, well, again, one of those things I think that's better seen than that is better demoed than actually shown by way of slides. So to do this, I'm going to look at another demo I have here, and this one uses another manifest file. And it's going to look very, in this one, I want to use the manifest file to define my routes. So basically to do this, I'm going to turn on something called an Ingress up here, and this is going to tell Kubernetes, hey, use an Ingress controller. And behind the hood, behind the scenes, under the hood, this thing is really just using Nginx to do the magic. So it's basically configuring Nginx for you by way of some specs that we have defined below. And to do this, what I need to do is turn on some HTTP routing, so that the code that will translate my routes into to routes behind the scenes to go back to my services will get interpreted correctly. And then I'm doing basically a rewrite on everything that will get rewritten back to a slash here. So I want to have rewrites enabled so that if I type in something random, it will actually just interpret that as something that gets appended to the base as well. And then this right here turns on I need this for WebSockets to work. And I'm going to be using this as a demo for WebSockets as well. So down here is where I have the paths defined. So in this particular demo, I have 4 paths defined. I have the root defined. I have app1, app2, and then I have my Commander Keen pod again. And these get routed to different service names using a selector right here. And this is what I remember when we talked about labeling back when we looked at pods, and we do other kinds of labeling for things like controllers. It's going to attempt to match this service name right here based on the selector right here. And so it's going to attempt to route this path to this service, and this path to the same service, and this path to this service, and then this path to this service. And then below, I have basically the same kind of thing that we saw before. I have a service exposed, but this time I have it exposed on a cluster IP address. And the cluster IP address, remember, is an internal IP address because the Ingress controller is what's going to get the public IP address. And then I have a few more of these. Then I have the deployment for this defined right here. So this services for this deployment, and again, it's defining a replica set of 3 of these given this different node application that basically reports data back to my application. And then there's the container spec. So I'm going to end up, when I deploy this, I'm going to end up creating 3 different deployments, so for a total of 7 different containers that are all going to be running. So because I have 3 replicas in this one, here's another service, and then here's the 3 replicas in the second one, Node App 2, and it's got another service exposing this deployment. And then here's my third service that we just saw a minute ago. This is my Commander Keen service, and it's got another deployment down here for that one pod. So this is again defining a Ingress controller that's actually load balanced, that's actually doing URL-based routing across 3 different services that are doing load balancing across 7 different pods. So let's go ahead and deploy this using my Kubernetes cluster here. So if I do cd ... go back to demo 2, and then I do dir, we can see that's where the file is. And this is a simple Node.js application that's going to give me some information about my Kubernetes cluster. So if I run that exact same kube command again, kubectl get create -f, and I do ingress service and deployment and run this, it's going to it's already got a service named Keen. So what I need to do before I do this is I'm going to do cd I should have removed this, demo 1. I can do a kubectl delete -f, and then I can pass in that keen-yaml, and that will actually remove the file itself. Let's see. I'm not in the folder. What does that say? kubectl. I misspelled it. And that will delete those services. And then I can go cd ... demo 2, and then delete the one I just did because it probably made a mess of things, and delete that. And nothing. Everything was deleted, and everything's a clean slate again. And then I can do a create on that same file, and that will cleanly create everything now. So now I have those pods created. I should have 7 pods 3 services and then 1 ingress. So if I do get kubectl get pods, I should have 7 pods. That's the one I just had. That's terminating. That's the one that from the first demo. Here's the 7 new pods right here. And then if I do get services, I should see 7 of these besides the default Kubernetes service. And there's the Keen service, and then there's the 2 other services I created. And then if I do get ingress, I should only see 1 ingress right here. And there's the 1 ingress, and it's already grabbed a public IP address. So with this, I should be able to grab this IP address and pull it up in the browser as soon as I get all my pods up and running. And they're all in a healthy state. I've got 7 pods, all of them running. So let's go back to my browser, and this should be paused. It's because it killed that container. I can go HTTP and reuse this window and go / and that's going to pull up my app1. Notice that route went to app1 right here. And so I can refresh that, and that's pulling up that load balance behind node app1. So that's the 3 pods that we saw just a second ago right here. So node app1 is balancing between these 3 pods. Let's go back to the browser. If I do if I do a / app1, then that's going to give me the same pods that I was just looking at. So whether I use app1 or just /, that's going to give me the same set of pods because I had that route defined to go to that same service. Let's do another one for app2. And this is going to expose app2 right here. And notice this one is using app2, but I'm using a different set of pods, which are these pods right here. And those have a container running in them as well. And then if I do /keen, that's going to pull up that Commander Keen pod that we saw a minute ago, except this is a new instance running inside of my instance here. So I need to do keen /vnc .html. It tried to rewrite the URL. There we go. And let's go I think I need /keen here. And then I need to put in the password, pwd123 for my super secure password there. And there I'm inside of my Commander Keen pod again, and I can go cd keen and then install my game again and install this guy. I'm zoomed out too much. And then I can play Commander Keen for kicks because that's really what I wanted to do on this demo anyway, is play Commander Keen because I had an awesome childhood and got to play this computer game rather than my Nintendo games because I didn't have a Nintendo. I had a 286 that I used for gaming instead as a kid. And I don't have sound for this, though, unfortunately. I haven't figured out how to do that yet on this. But in any case, the demos that today have demonstrated a service, it demonstrated an Ingress controller, and we looked at pods, and we looked at Azure Kubernetes Services and how to create this and how to do some of the annotations on this. So now I want to take questions. We have about 15 minutes left for questions, so if you do, please pose those questions over here in the chat box. But before I do that, let's go back to the deck. I'm going to throw the question slide up just to point out what we've talked about and then wrap up. But before we go and answer questions, please do check us out online at WinElect.com. We're constantly posting stuff about various things related to Azure technologies. We have some ongoing series related to Azure B2C, which is an authentication mechanism for Azure B2C clients. So that allows you to use things like Facebook or Twitter to authenticate against your applications. And we have some ongoing content related to container technology as well as a lot of other things so check that content out online and check us out there. You can also follow us on WinElect to find out when things are happening at WinElect. We post about new upcoming webinars and upcoming content that we have inside of our dev pages on WinElect.com, so you can check out that and just stay up to date on what's going on at WinElect. And you can follow me online at the One Mule, where I post stuff about the same kind of things as well. And then you can also check out our YouTube channel, where we will be posting this video as well as recordings of our past webinars. And then I also have a lot of container related content out there related specifically to Azure Kubernetes Services, that we're doing an ongoing series on that right now on our website, on our YouTube channel, where we've talked about Azure storage as it relates to Azure Kubernetes Services, or how to use how to use security features on Kubernetes, or how to use Azure Container Registry, or things like that, and where I go into a lot more detail than I can in a webinar. And you can follow those videos on our WinElect Now channel there. So I'm gonna pop out the questions and let's see what we have here. Let me pop this out, and then I'll drag it over to the and start answering some of these questions here. So the first question, start at the top and then say, take it away. So the first question is and does it have limits? I don't see a context for that. I'm going to say, let's see if it's, first one is and does it have limits? But is it the same? I'm not sure what the context is. Does Kubernetes have limits? Yes. Oh, that's an old one. That's not an old. That's a new question, not an old one. Can the whole AKS cluster, including the API server, be on an internal network? An AKS cluster, by default, the API server is managed by Microsoft, so it's not explicitly part of your AKS cluster. So it's not a part of your internal network. However, the nodes that run your applications can be completely on an internal network. You don't have to expose those to the public internet. But you remember when we created the VNet, the ability to create that VNet only requires that you expose the nodes to that Azure VNet, and that VNet does not require that you expose anything to the public internet. And so if that VNet is joined back to your on-premise environment by way of a VPN or an express route, you can definitely use Azure Kubernetes Services as an extension of your on-premise network, and then it'd be completely private without having to install and manage a Kubernetes cluster on-premise. So it's a great way to extend your on-premise environment into Azure, and then let Azure manage the Kubernetes cluster for you, and then you can actually take advantage of all that. So yes, so you definitely can use AKS as part of a private network, but not so much not everything in particular, but that part you can use the webinar. I'm sorry, the worker nodes. Next question is, can an AKS can this seminar be posted online for those who can attend? Yes, this will be online. To answer that question, Azure. Another question related to this. Let's do these by time. All right. One more of the fundamental series be configured for containers on Windows with SQL for Windows. I know there's a version for Linux, but I have not seen a Windows version. I don't know that Azure SQL for Windows in a container. I'm not familiar enough in the SQL space, but I do think there is a version of SQL Server that you can containerize and run that on a Windows container. You'd have to double check me on that, though. I'm not 100% sure that it's been completely ported to a Windows container, but I think it has, and there's images for that on Docker Hub if you want to go out there and check those out. But I do know that SQL Server is available on a Linux container, and you can definitely run that on Kubernetes. Let's see. Some technical support there. Virtual nodes are no longer in preview. We've been using them, virtual kubernetes to run Windows containers. That's from from somebody that's mentioning that they're using virtual nodes, which is cool. I ran into some issues with them. That's kind of why I'm using with reservations. Like when I was deleting some pods running on virtual nodes, it ended up deleting the virtual kubelet, and I had to actually go back and re-add it to the Kubernetes cluster, which was one reason why I had reservations about doing it that way, because it shouldn't be the case that I actually have to delete the virtual kubelet when I delete a pod that was running on that. So I ran into some issues with it. That's just personal experience that I've seen with it, but I think that eventually will get ironed out, and they will become more readily available there. For monitoring, do you find that Azure provides the tools that are complete enough to do, or would you look into another solution? For monitoring, I think it provides a sufficient amount of tools, but it's not going to be specific enough to specific applications. The the tools on Azure are very Azure specific tools, and so they're really good at doing things inside of AKS, but they're not going to be able to be ported to other environments so that you could use them in other environments, such as an on-premise Kubernetes cluster. So my advice there is if you want to use the baked-in tools, they work great. There's nothing. I don't think they're lacking in features, but I just don't think. But if you're used to using other tools, then you can certainly use those in Azure Kubernetes Services as well. So to me, it's 6 one way, half dozen another. It's really depending on what you wanted to use. Next question is can an AKS cluster, including the API? Okay, we already addressed that question. I have 2 web servers, IIS and 1 SQL server. How would Docker help me if the SQL is SQL is if the bottleneck is SQL? If you have 2 IIS web servers and 1 SQL server, Docker gives you the ability just to basically containerize an application. So the paradigm is a little different with a Docker image. So you wouldn't, like, if you have a web server such as IIS and it's running like 6 different web applications, you wouldn't take that entire web server and put it in a Docker container. Instead, what you would do is you would actually take that each one of those applications and containerize each one of those separately from one another, and then deploy each one of those as a separate Docker image and separate container inside of a Docker environment, such as Kubernetes, using Windows containers. And so what that allows you to do is manage each one of those Docker containers as an independently deployable stack, rather than having to manage a single web server for managing 6 or 7 web apps. And so that's the difference between a IIS deployment and a Docker deployment, or IIS deployment and a Docker-oriented deployment, because Docker, really the best practice is to have one application, or really one application component per container. So in the case of an IIS workload, if I had a database that was supporting a given application, I might break that database up into multiple databases. If it was multiple applications using separate databases, and containerize each one of those databases separate from the application, and have a container for a database and a container for the application, rather than put those into one application. There's a lot of different ways to do that. If I was running it on AKS, I would probably put all my SQL onto Azure SQL and then let Kubernetes actually run my application, or even use something like Azure App Services. Depending on, there's a lot of different ways you could go about solving that problem. But basically the difference between Docker and IIS is used for managing web apps on a single web server, while Docker, you would want to put one application in a given container and let that one application exist independently of a bunch of other applications on, rather than trying to cram them all into a single container. If the current deployment does with in-app service plans, what is the advantage of moving to AKS or Kubernetes? If you're using app service plans, that's to say there's an advantage to Kubernetes. I'm not going to say there is an advantage to Kubernetes. The one advantage of Kubernetes, I would say this, is Kubernetes is more is a little less opinionated, I guess, than app services is. In fact, app services can run containers as well. So, I mean, it's an option for running containers on Kubernetes. The one advantage of using containers is if I want to use Kubernetes on premise or on a different cloud or on Azure, I just build my container once, and then I can deploy it into any one of those environments. And given that you can do that, you can run containers on app services. That's kind of a moot point even so. But even what Kubernetes does give me a little bit more advantage is that I have a little bit more control over the environment than I would with app services, and that I can kind of more finely tune the behaviors with controllers. I can more finely tune some of the behaviors of the clusters and determining the sizes of them. App services is going to have limitations on the size of, like, the environment, for instance, the amount of compute I can throw at a problem, while Kubernetes can scale up to a much larger deployment than I would get with something like app services. But if you're already using app services and you're happy with that, and it's serving you, I would not encourage you to go to Kubernetes, because you're really not going to gain anything if it's working well in Kubernetes, already running well in app services. Is it possible to, next question is it possible to change the size of the cluster after its creation? Absolutely. You can add, there's two ways to do that. You can add more nodes to it by adding more nodes. Like we saw the slider when I was going through the creation wizard. I can take that same node, same slider once it's deployed, and deploy additional 100 nodes to my cluster. I can also remove nodes as well. I can create auto scale on my cluster as well that will automatically increase the size of it. Also, Azure Kubernetes Services and other Kubernetes as a service instances have this concept called node pools. And what node pools allows me to do is have different sets of compute. So if I want to have a set of compute that is designed more for big data, that's got more compute hardware associated with those nodes, in other words, they're larger VMs, I can have a node pool that is designed that has a bunch of VMs that had maybe 4 cores or 32 gigs of RAM, but at the same time, on my same cluster, I have another set of nodes that are basically just doing serving up web apps, and it's mostly static content. Well, I can use a more modest VM for that. I only need maybe a single core VM, and I can have 2 separate node pools, and each one of those can scale independently of one another as well. So there's a lot of ways to add capacity to an Azure Kubernetes cluster. Hey, thanks for that. That was amazing. I was happy to give the webinar. How can we create, another question is, how can we manage certificates with an AKS like client certs? I'm assuming you're like talking about client certs such as for authentication, or maybe some kind of, I'm not sure what the client certs for, I guess that would be like PKI. AKS does integrate with Key Vault, Azure Key Vault, and you can store certificates there, and you can mount Key Vault into AKS as a mounted volume essentially, and it shows up as a mounted volume that can be read by applications inside of the Azure Kubernetes cluster. So it basically means that I can store my certificates on Key Vault and then expose those to my application. So if I want to do that, that's one way to manage that. You can also use Kubernetes secrets to do that. And Kubernetes secrets, I didn't go over secrets because it's an advanced topic, but it gives you the ability to store those in a secure way on Kubernetes itself. But if you're going to be using AKS, I would use Key Vault to store client certificates or any kind of certificates or connection strings or anything like that, and then expose those to the application by way of mounting the Azure Key Vault as part of my pod, and then that becomes available to the application that can read things out of that secured storage that comes from Key Vault instead of making that as part of a configuration file or something like that. Next question is it common to see companies using pods or creating virtual web servers in Azure? If we use PaaS services from these virtual servers, are there actual pods behind the scenes? I'm assuming that we're talking about Azure Container Instances maybe here. They're pods behind the scenes. Azure Container Instances is a platform as a service implementation for containers, and behind the scenes it's using Kubernetes, it's able to it just doesn't expose it as a Kubernetes pod behind the scenes. So if you use pods for these virtual servers, then are you using pods behind the scenes? Yes, you are, and they show up as pods in virtual kubelets, and I think we did talk about that. I haven't seen a lot of companies using virtual nodes yet, but as far as I know, that we did have one person mention that they were using them, and again, I gave some reservations about it. But even so, the ability to use those is available now, and encourage you to look into it just so that you can kind of project if you see if it's a feature you want to use and see if it will meet your needs. And does it have any limits? I guess that would related to the question related to client certificates, and I think it doesn't have any limits as far as I know. That's going to be limited more by the storage available on Key Vault, as I mentioned there. Next question is, how does AKS log and monitor a dashboard? What does that look like? It looks like it uses Azure Monitor behind the scenes. So if you've ever seen Azure Monitor, basically it's just it takes the metrics and then from AKS and then displays those on a dashboard that you might see if you're familiar with what Power BI dashboards look like. Very similar to that. If you're familiar with Azure Files, Azure Monitor dashboards, it's basically going to show you some like KPIs. Like maybe, number of nodes that you have, number of pods you're running, what's your CPU threshold look like, and it can also give you some information about that kind of thing. So you can have those kinds of dashboards like that, and you can drill down into those and get things like log information and all that kind of stuff out of those same kind of dashboards that you would expect. Can we remove nodes to the master on the fly? Not master nodes, because those are managed. Next question is, can you remove master nodes to the fly on the fly? Because the master nodes on Azure Kubernetes Services are managed by Microsoft, so you never actually see those. You do see the worker nodes, and yes, you can remove those on the fly without a problem, as we discussed already through Autoscale, or you can do it right in the portal, or you can do it through the Azure CLI. Let's see. Next question is, regarding Ingress and load balancing, my situation has been a .NET Core containerized app that is sidecar container and that uses Nginx as a reverse proxy that uses for HTTPS termination. Would the Ingress load balancing be a good candidate to allow the removal of the proxy, in my opinion? Absolutely. I would go much more down the road of using Ingress controllers and services before I ever used a sidecar container to do reverse proxy. Rather than have two containers in a pod, I would definitely go down the road of using Ingress for that, because that's exactly the problem it's trying to solve, and it's going to do it a lot better than a sidecar container using Ingress and using the actual using Nginx as a way to do that Ingress and SSL offloading and that kind of thing. I would go with the Ingress route over the sidecar container route any day, unless the only caveat I would make to that is if the sidecar container is doing something using a very esoteric Nginx configuration, then I would be a little bit more hesitant to advise you to abandon that pattern. However, I would probably do it a little differently in that I wouldn't use a sidecar pattern. I would probably just expose it as something like a daemon set and let that daemon set be an Nginx controller, work like a controller, but use my very specific configuration of Nginx. But by and large, the Ingress controller that's available inside of Kubernetes can do a lot of the common things for reverse proxying that we're used to. It's only in those edge cases where I need very specific tuning of Nginx that I would actually go down the route of using something other than the built-in Ingress controller. Let's see. How is Docker going to help if the the bottleneck is a SQL Server? And this is related to the question that we just had, related to SQL Server and containers. Docker's not going to help with that at all, really. I don't think that's that's not going to make this. If you're having struggle with the SQL Server, then the problems are with SQL Server, and putting that in Docker is not going to help that at all. In fact, it might make it worse. And so I would go about trying to figure out why SQL Server is slow in that if that's your bottleneck. Do some query optimizations, look at some of the metrics coming out of SQL Server to diagnose why that's the problem and what's going on, and to figure out how you can make your SQL Server run better, because putting that in a Docker container is not going to help it. I promise you that. It's probably going to make it worse. The next question is how well does Autoscale support in AKS? It works pretty well because it's based on a tried and true technology that is under the hood in Azure. It's VM scale sets, and because all the container nodes on Azure are basically identical to one another, it fits well into that, and that's actually brokered by Azure Monitor behind the scenes. And so basically, it's just using something that's already built into Azure to control that. And so that Autoscale feature is already well baked. It's just being exposed in a more native fashion whenever you enable it, and you can control it by way of the Azure CLI. But the Autoscale feature is being brokered by something that is controlled by Azure under the hood. So that's really what we're doing there as well. So something to think about there as well. One of my monitors just went out. I don't know what happened. brought all the questions over to the screen. So let's see. Last question is how can manage the price of all the components of AKS inside of Kubernetes? You can manage the price of Kubernetes price by looking at what it does is what Kubernetes does behind the scenes is actually creates a resource group that has all of the Azure resources exposed to you inside of your Azure subscription. So you can see those resources, and you can look at those resources, and you can see what's being created and what's being used, and then you can use that to kind of get an idea of what it's going to cost to run to manage your cluster. Because basically all you're paying for on a Kubernetes cluster is Azure resources, and it's just, but the Kubernetes aspect is really what the sum total of that is. And the lion's share of that's going to be mostly oriented around workloads related to Azure VMs and that kind of thing. So my monitor just came back on. In any case, let's see if there's any more questions. So how can you manage price? That's the last question. So I think we've gone a little bit over, but I want to thank you guys for attending, and we will make this available online, and want you to check us out on our website and check out our YouTube channel and check us out on Twitter. And until next time, look forward to seeing you on our next WinElect webinar. We're going to be looking at some technology. We're going to be looking at the next one I do is going to be on Docker files, tips and tricks, where we're going to look at how you can optimize container builds related to Docker files, and how you can optimize the build process using various features on Docker CI and CD pipelines using Docker files as well. So until next time, thanks for attending this WinElect webinar, and I look to see you on a future one in the coming weeks.